In this video, we will see what is conventional tolerancing method and limitations of conventional tolerancing method, advantages of GD&T method. First, conventional tolerancing method. In general, manufacturing tolerances allow parts to deviate from perfection, but only within specified limits. The amount of tolerance allowed is usually based on part function. The limits allow the part to deviate, but a properly applied tolerance will ensure that parts fit properly and function as intended. When tolerances were first introduced, they were very simple. Every dimension had a plus or minus tolerance. If the drawing dimension stated 2-inch plus or minus 10 mils, then an acceptable part would measure between 1.990 inch to 2.010 inch for that dimension. In conventional tolerancing method, all the dimensions are specified in plus or minus tolerance. Even position also defined with plus or minus tolerance. As engineering progressed and parts became more complicated, a new method of implementing tolerance was created, that is geometric dimensioning and tolerance. Limitations of conventional tolerancing method. Datums are usually not specified in the conventional tolerancing method. Consequently, machinists and inspectors do not know which datums apply or in what order they apply. Datums are required to relatively position the features with respect to another feature in the same part. The plus or minus tolerancing system, that is conventional tolerancing method, generates rectangular tolerance zones as they don't use diameter symbol. Size features can only be specified at the regardless of feature size condition. Regardless of feature size means that the location tolerance remains the same no matter what size the feature happens to be within its size tolerance. For example, consider a hole feature. When hole size increases, it has more location tolerance, but there is no way to specify that additional tolerances with the plus or minus tolerancing system. This picture shows what will happen if datums are not specified in the drawing. With the traditional method of tolerancing, it is not clear whether the lower edge of the part should be resting against the horizontal surface of the datum reference frame or whether the left edge of the part should be in contact with the vertical surface of the datum reference frame. Manufactured parts are not perfect. It is clear that when drawings are dimensioned with traditional tolerancing methods, a considerable amount of information is left to the machinist and inspector's judgment. If a part is to be inspected the same way every time, the drawing must specify how the part is fit in the datum reference frame. All of the datums must be specified in order of precedence. Figure 1 is an example for traditional tolerancing method. Here you can see all dimensions are specified in plus or minus tolerances. This is a rectangular part with a hole on it. The whole axis is positioned by two positional dimensions from left to right, from bottom to top. These two positional dimension tolerances plus or minus 0.005 inch will generate rectangular tolerance zone. In rectangular tolerance zones do not have a uniform distance from the center to the outer edge. In figure 1, from left to right and top to bottom, the tolerance is plus or minus 0.005. Across the diagonals, the tolerance is plus or minus 0.007. By using Pythagoras theorem, we can find the diagonal length. Diagonal length equal to square root of 0.010 square plus 0.010 square. We will get 0.007. So the diagonally we have more tolerance. Therefore, when designers tolerance features with plus or minus 0.005 tolerance, they must tolerance the mating parts to accept plus or minus 0.007 tolerance. Because consider the mating part for this hole is a pin. The pin axis should have plus or minus 0.007 position tolerance. This is one of the limitations of conventional tolerancing method. Let's see the advantages of GD&T. There are three advantages of GD&T tolerancing system over conventional tolerancing method. The first one is datums. Datums are used to position the features relatively. Second, maximum material condition. With the material modifier symbol in feature control frame, we can get bonus tolerance. Third, with the diameter symbol in feature control frame, we get cylindrical tolerance zone, which is 57% more tolerance than rectangular tolerance zone. In this figure, the tolerance zone is oriented perpendicular to datum plane A and located with basic dimensions to datum planes B and C. Basic dimensions have no tolerance directly associated with the dimension, thus eliminating undesirable tolerance stackup. The full length of the axis through the feature is easily controlled because the cylindrical tolerance zone extends through the entire length of the feature. Unlike the rectangular tolerance zone, the cylindrical tolerance zone defines a uniform distance from true position. When a 0.014 diameter cylindrical tolerance zone is specified about true position, there is a tolerance of 0.007 from true position in all directions. A cylindrical tolerance zone circumscribed about a square tolerance zone, like the figure from the previous slide. So figure 2 has 57% more area than the square tolerance zone, in which the actual axis of the feature may lie. Hole diameter dimension is dia 3 to 3.030 inch. Feature control frame position tolerance is diameter 0.014 at maximum material condition with respect to datums A, B, C. A is primary datum, B is secondary datum, C is tertiary datum. Let's consider the actual manufactured size of the hole is 3.020. When part is manufactured at maximum material condition, the hole size at maximum material condition is 3. So, we get 0.020 bonus tolerance. The geometric tolerance is 0.014. So, the total tolerance is 0.034. When feature of size departs from the specified material condition, we get additional tolerance, that is called bonus tolerance. The least material condition size dimension of hole is 3.030. Let's assume the actual hole size is 3.030 inch dia. Then our bonus tolerance will be 0.030 plus the geometric tolerance of 0.014. So we will get total tolerance 0.044.